Hello and welcome to Maths with Jacob. This lesson will focus on distance between 2 points. The distance between 2 points. Consider the interval in the first quadrant of this number plane. There's the interval there, the actual blue line. The points at each end of the interval are 2, 1 and 5, 5. So there's 2, 1 and there's 5, 5. We can use these 2 points to calculate the distance between them, so we can actually find the length of the blue line. The next slide will present more information about this process. Let's have a look. So finding the distance between 2 points. The interval on the previous slide has been reproduced here, showing the 2 endpoints. So we have 2, 1 and 5, 5. That was on the number plane in the previous slide. I will now try to present a simple explanation on how to find the distance between these 2 points. In order to find the distance between the above 2 points, we insert some construction lines in order to form a right angle triangle. So you just do a dotted line here, vertical, and a dotted line here which is horizontal, and that is a right angle. We then calculate the base and the height from the given 2 points. After that we use Pythagoras' theorem to calculate the length of the hypotenuse. This answer is the distance between the 2 points. So the next slide will show what has been done in more detail. So here is the blue line. Here are the construction lines. There's the right angle. Looking carefully at this diagram, we can see that the height of the triangle is 4 and the base is 3. So 1, 2, 3, 4, that's 4 units. 1, 2, 3, and the base is 3. We can count the spaces to arrive at these 2 lengths, or the height is the difference of the y values. 5 take away 1 gives you 4. So remember, the difference of the y values gives you the height. And the base is the difference of the x values. So for the 3, we have 5 minus 2 equals 3. So we'll move on to the next slide. So, if we remember, the height was the difference of the y values, which is y2 minus y1. y2 minus y1. The base was the difference of the x values, which was x2 minus x1. So on the previous slide we saw that the height was y2 minus y1 and the base was x2 minus x1. We now use Pythagoras' theorem to work out the formula for finding the letter d. So I'll put d here as the distance between the 2 points. So Pythagoras' theorem tells us that the square on the hypotenuse equals the sum of the squares on the other 2 sides. So d squared equals y2 minus y1 all squared plus x2 minus x1 all squared. So d will be the square root of that expression there. This is the formula for the distance between 2 points. So whenever you have 2 points on a number plane, x1, y1 and x2, y2, that is the formula we use to calculate the distance between them. So for the example we have here, here is our formula, and all we do is we substitute in the coordinates. So y2 minus y1 is 5 minus 1, which is 5 minus 1, and x2 minus x1 is 5 minus 2. So we've done the substitution there. So 5 minus 1 is 4, 5 minus 2 is 3, so we end up with that line. So d will be the square root of 16 plus 9, so d is the square root of 25, so d is 5 units. So this video has given us a simple example which illustrates how to find the distance between 2 points on a number plane. And we've seen how we set it up with a right angle triangle. We've seen how we use Pythagoras' theorem to arrive at the formula, and then we've seen how to use the formula to actually find the distance between the two given points.